Notice the stainless steel pipe has no gaps. How do we achieve complete penetration welding? This is an 80 ASCH 10 stainless steel pipe, about 85 mm in diameter and 3 mm thick. If the molten pool doesn't penetrate the pipe while welding, it won't oxidize or introduce gas. To weld inside a stainless steel pipe, gas must be introduced. Several welding methods exist. You can use a swinging method like that for welding pipes. There are also methods for welding bit by bit. The key is to feel the molten pool in the pipe. To learn this feeling, it's best to reduce it and build it gradually. I will use a current of 180. Both pipes have no bevels and no gaps. Even in these conditions, I will show you how to perfectly weld a pipe. Welding without movement deepens the weld pool until it penetrates the pipe, then, the pool's vibrations are minimal, and it's vital to sense the pool's subtle waves. If the pipe is thin or angled, the part's thickness will reduce, allowing the weld pool to penetrate the pipe easily. If the pipe is thick and cut at an angle, passing a thick pipe through the weld pool can be tricky. Plus, there's the burden of heat input, because it requires more heat than a thin pipe. Yet, it is a viable method, because it significantly reduces the work process. If you feel a small wave clearly, you can also apply it to swinging techniques. Another method is to weave like welding pipes. I will introduce you to this method later. The timing of electrode supply doesn't seem important. You can drop a drop after the wave forms, melt the electrode to create a pool and then fuse it. You can provide it in the middle. You can try this and that and use the right methods. And I'm showing you this way today as well. If heat rises too high, it may create a large hole in the melt pool. It becomes burnt through. Press the start button to create a crater current before the hole opens. Then welding can proceed while maintaining a constant heat. This is the principle of welding, repeating it. I will demonstrate it again. First, weld it in place. As the penetration deepens, the melt pool will eventually penetrate the pipe. Small waves form in the melt pool. Then, provide a drop of filler rod. Press the start button before opening a hole in the molten pool. Then, stabilize the molten pool, because it turns into a low current. At this point, move the torch slightly forward. Release the start button to initiate welding current. You can feel the subtle waves again. You can repeat this process to weld. This is what the inside of the pipe looks like. The current is a bit high. A current of 160 is enough. As the pipe gets thicker, this method requires more heat. So, the weld surface may turn gray. Of course, there are ways to solve this. I'll introduce it to you later. You can use a wire brush to clean the part and do the final welding. Finally, it's best to lower the current a bit while welding. You can switch to 4T mode for welding. That completes the welding. If used in sanitary pipes and similar contexts, the welding method shown today may be effective. It can also weld small diameter pipes. If it works on a rotator or turntable, it could apply to low-pressure tank welding. The welding method isn't always the right choice, but it's one of many applicable methods. I hope this is helpful to you. Thank you for watching.